Now this question has two triangles separated. Sometimes these pictures have the triangles within each other, so sometimes you'll see pictures like that, but all the time it's about the same principle. They're telling you that they are similar. They won't always tell you that. So for example in here you wouldn't know that the two triangles are similar directly, although they would probably put on the fact that those two are parallel, so therefore you know that that angle is identical to that angle is identical to that angle because they're corresponding angles, and this is a common angle to both big triangle and little triangle. Therefore, because all the angles are the same in both shapes, there's an enlargement of each other, so therefore they are similar. So they're telling you they're similar. Well, that means then there must be a scale factor, because similar shapes are just an enlargement of each other, where the angles don't change, but the side lengths change. All the side lengths change in the corresponding way by the same scale factor. So recommended technique is find the scale factor between the two shapes. Now the scale factor is simply defined as the new length of the new shape divided by the old length of the corresponding side. So the scale factor is new length divided by old length, where you've got corresponding sides. So we can see on these pictures that they've been nice to us. There's our corresponding sides, 6 and 4. So our scale factor is going to be 6 divided by 4, which you can work out to cancel the fraction as 3 over 2, or you can work it out as 1.5. It's whichever way the scale factor is going to be, 6 over 4 or 3 over 2 or 1.5. Personally, I prefer to use 3 over 2 because that's going to make it an easier sum to do when we're doing our multiplications or divisions. So let's have a look at the question once then. So it wants you to work out the length of DF. Well, we look where DF is, and DF is this bottom side here. So we want this length there. Now the corresponding side is that one. Now we worked out the scale factor that went in this direction, so the scale factor was going from the small shape to the big shape, and we worked out the scale factor was to multiply by 3 over 2. So in other words, to multiply by 1.5. Take the 9, multiply by the scale factor, because it's similar shapes, then the same scale factor works for all corresponding lengths. So we're going to do 9 times 3 over 2. And basically, the best way of thinking about this is all whole numbers, integers, are fractions. They're just over 1. We just don't write the over 1 bit to simplify things in maths. And when we multiply fractions, you've got to remember that you times the numerators and you times the denominators. So we end up with 27. 1 times 2 is 2. That means 27 divided by 2. So the answer is going to be 13.5. So the answer here will be 13.5 centimetres. Now, if you don't like dealing with fractions and you prefer to think of this as 1.5, then you would have just simply done 9 times 1.5, which you should recognise is the same as 9, the original whole one, plus a half of 9. Well, 9 plus a half of 9 is 4.5, so that would be 13.5. Either way, you get the same answer, 13.5. Now, the next part of the question wants the length of BC. So BC is this side here, and we've been given the fact that this length is 10.5. So this time we're coming in the opposite direction. So instead of timesing by the scale factor, we're going to divide by the scale factor. So we divide by 3 over 2 to get that length there. So we're going to be doing 10.5 divide by 3 over 2. Now again, there's lots of ways of thinking about this, but it's critical really in a sense that at this level you're kind of thinking of how do I divide by fractions. Well, we turn it into a multiplication sum by taking the reciprocal of the second fraction and turn it into a multiply. So the reciprocal of this means 1 divide by it, which means it will flip over, it will turn into 2 over 3. So the question is asking us to do 10.5 times 2/3. Well, again, think of 10.5 as over 1 times by 2 over 3. So 10.5 times 2 is 21. 10.5 is 21. 1 times 3 is 3. And 21 divided by 3 is 7. So the answer here will be 7 centimetres. So the key to this topic of similar shapes is once you know you've got similar shapes, they either tell you or you can see it by all the angles in the corresponding shapes are the same. And they're just an enlargement of each other. So a little triangle, big triangle. Work out a scale factor by finding corresponding lengths that they've given you in the question. So they gave us 4 and 6, so I can work out the scale factor by dividing the new length by the old length. That's my multiplying factor for going from the small shape to the big shape. So every length in the big shape is times 3 over 2 bigger than the small shape. If you go the opposite direction, I divide by the scale factor. And then it's a case of just putting the numbers in, guys, and recognising how you multiply fractions is usually the best way to do this topic, because most scale factors on non-calculated papers where this is a popular topic will be using fractions. That's similar shapes and how to deal with them.